a huge 3D mission to share our abilities with astronomy in order to preserve dark, starry night skies. All right, well, save our stars. So it's a dark skies.
Hi, I'm Alicia, and I'm a producer. Think there's something you can do to help protect birds in 1 minute? Watch this. Many species of birds hunt or migrate during the nighttime hours. However, due to the brightening of the night sky from artificial light, birds' hunting patterns and migratory abilities can be disrupted. One source of artificial light affecting birds is from tall buildings and towers. On foggy nights, migrating birds are drawn towards lights in cities and may collide with lit buildings or circle them until exhausted. If you work in a high-rise building, it only takes a minute to talk to your boss or the building's landlord about the possibility of dimming or turning the lights off when the building is unoccupied. This will not only help the birds, it will also consume less energy and save the building's owner money. It's been estimated that 100 million birds in North America die each year due to a collision with lighted buildings and towers. But if you have even 1 minute, there's something you can do about it. Be the change you want to see in the world. Come on, let's show what you can do.
Do you guys want to watch the 3D?
Yeah.
Yeah. And where do I stand? There you go. Look at that right there.
Can't really see it.
Oh, from your point?
Yes. From Leonard's telescope right there.
It's like right there.
So we're outside. We're outside. It's about I don't know, 15 feet across, 20 feet across screen. And they got these really high definition shots of the moon from their telescope, which is what they're showing right now. It's too dark to see any of the scopes. There's a bunch of scopes here. One guy just told me his can go out to 400,000 light years. Not sure what that means.
This magnificent cosmos, and more than that, we love sharing it with you. One of our astronomers, Michael Romelin, does Astral Imaging, That's a science of photography where you use very sensitive cameras with discrete filtering. And with that, you're able to look deep in deep space and take photons and sort them out and reassemble them based on many, many, many stacked images and create what you're seeing now. And this file that we're going to show you right now is a collection of the most recent images that's been created by Michael Romulan. Mike, are you around? I want you to come down here and tell people what we're seeing. Would you mind? And I want to introduce Michael Romulan. Are you right there, Michael? It might take him a minute. He's manning his scope up there, but here you're looking at the Eagle Nebula, and I think I'm seeing what I'm seeing is the pillars of creation. I could be wrong. I need him to come and tell us. It could be Lagoon, and we're looking at some pillars, but you see the great structures there, the filaments. Here's Michael, everybody, and he'll tell you about his images.
Hello, everybody. I'm going to wait for the next one here.
Well, tell them what they're seeing now. Are you going to wait till he comes back around?
Wait.
Okay.
Is it going to come back around?
I think so.
Oh, here we go. This is a very popular one, the Lagoon and Trifid Nebula. In the summer Milky Way. If the moon wasn't out, we'd be able to show it off. But two huge nebulas, star-forming regions, relatively close to each other. So I was able to capture it in one image. So this nebula is lit up by the star cluster in the middle. It illuminates the entire nebula.
How far away?
I believe about 2,000 light years.
We're telling emissions and reflection nebulas.
And the Trifid's actually a bit of both. It's an emission nebula and a reflection nebula.
And what are they?
An emission nebula is illuminated by itself. It's ionized. Reflection nebula is usually illuminated by star clusters or stars within it.
I don't think I'm all here yet.
No. This is one of my newest ones, the North America Nebula. Resembles the North American continent. This one took forever. I spent about 20 hours worth of exposure time on this one. Imaged from a light polluted cathedral city. Took many hours to get it, but very beautiful. All the red you're seeing is hydrogen gas, which is probably the most abundant thing in the universe.
Starbirth.
It's the fuel of stars.
Are these artificial colors?
No.
Real colors.
These are real colors, yeah. Hydrogen usually shows up as red. Ionized oxygen usually shows up as like a blue-green. And then we get a combination of both of them, and you get the pinkish colors. This is the Pelican. I think it looks like what's the old flying dinosaur, a pterodactyl? I think it looks more like a pterodactyl.
Phoenix.
A phoenix.
And even a dragon.
There's some nice
Game of
pillars in
Thrones.
that one.
Where's that one? You point?
You got the laser pointer?
Yeah.
The North American and Pelican are both up by Deneb up here.
See?
Right over here, right by this star.
Hey, use the microphone, Michael. They can't hear you in the back. People, they need to hear you way in the back.
So this is a beautiful wide field shot of the North American and Pelican. They're right next to each other. The first two images, I kind of highlighted them individually, but this one is the whole shebang. And as it zooms out, you'll actually be able to see them both. And that's it. Thank you.
All right, Michael. Yeah, the stuff you see in these things, I mean, what makes up all these things are inside the Milky Way, in our galaxy. These are not things that are outside our galaxy, although all galaxies have these things. And what you're looking at is regions where intense collections under gravitational force of dust and have come together, and there's star birth going on. You'll see a number of things. One of the things you saw look like black areas. They're actually dark nebula, which is super dense dust that is collected and is blocking out all the starlight in behind. And you can see there's dark nebula areas in this. This is like a planetary nebula, this one. I don't know exactly what the name of this one. Which is this one, Michael?
Cocoon.
The Cocoon, and I think the Cocoon is a planetary nebula. Planetary nebulas are the remnants of stars about the size of our sun. If they don't form a planetary nebula, they probably are going to form a supernova remnant. That's the other form of what stars can become. Stars in their evolution go through phases as their material burns up, like our sun is doing right now. That is half of its way through its life, at 4.5 billion years old, we estimate, with another 4.5 to 5 billion years yet to go, will one day run out of fuel. And when it runs out of fuel, it's not going to be able to support itself any longer, and the thermonuclear reactions that sustain its ability to be a star will begin to falter. It'll go through stages that eventually cause it to explode in a nova, making an object very similar to this.